Okay, this is the introduction to section 8.3, part 3. We've talked about all the trig ratios. We've talked about how to set up the trig ratios. We've talked about how to find a side. The one thing that we have to do yet is figure out how are we going to be able to find an angle if I give you all the side measures. Okay, so in this case, as you look at the top right of your last page here in section 8.3, it says inverse trigonometric ratios. Okay, so in this case, you're going to need your calculator with you, and we'll go through class at the beginning of class tomorrow, and I'll show you exactly how to type this in your calculator, because you're going to need that. Now, the inverse is how we figure out the measure of the angle. So, for example, in this case here, you have the inverse tangent, the inverse sine, and the inverse cosine. Okay, and if you remember, tangent is opposite over adjacent. Okay, so what they do here is they say the tangent of angle A is equal to x. Well, in this case, x is opposite over adjacent, and that's what they've done here. Okay, so as we look at this here, if we were to set this up, this would be the tangent of x, or tangent of A equals opposite of angle A is BC over adjacent, which is AC. Okay, and now what they're doing here to solve this, you can't just divide by the tangent. Okay, it's something that's hooked up to that A, and that you can't just divide it. It's not multiplication, in other words. All right, so the inverse tangent to the -1, that's what they call the inverse tangent, or the inverse sine, or inverse cosine. That to the -1 is like the opposite of, like, multiplication is division. The opposite of addition is subtraction. The opposite of the tangent is the inverse tangent. Okay? So anytime you have the example where you have the tangent of some letter equals a fraction, in order to solve it, we're going to take the inverse tangent, which is what they do in all three of these. Okay? Now, let's go through an example, and maybe you'll understand and see a little bit better as I go through these. Okay, it says let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measures of angle A and angle B to the nearest tenth. So, in this case, they give us a decimal here. Sine of A is equal to 0.76. So to solve this, I have to say now that angle A is equal to the inverse sine of 0.76. Again, the inverse, if you take the inverse of each side, the inverse and the sine will essentially cancel each other out. So, there's a button on your calculator. Most calculators, if you hit the second button and then you hit sine, you'll see sine -1 come up. And then you type in your number, which in this case would be 0.76. So if you have a calculator with you and you're typing that in, that's what you would type in. And when I type that in to my calculator, I end up with this as an answer rounded to the nearest 10. And what this is this is the measure of angle A. Okay? The measure of angle A is 49.5 degrees. So again, another example, cosine. Cosine of B is equal to 0.17. To find B, the angle B, I have to take the inverse cosine of each side. So the inverse cosine of 0.17, again, to do this on the calculator, you would hit second cosine and then type in 0.17. Or some calculators, you type in the number, then hit second cosine. And when you calculate that on the calculator, B equals, in this case, 80.2. Okay? So those are a couple of examples, once you've already set it up, what to do with the equation. Okay? Now, let's take a look at a couple of examples here. What is the measure of angle x to the nearest degree? So, in this case, angle x is right here. I've got to figure out what sides do I have from that angle to figure out what trig function I'm going to use. Well, in this case, I have opposite here, and I have hypotenuse here. So that tells me I'm going to use the sine. So in this case, the sine of x equals opposite is 6, hypotenuse is 10. Okay. So now I'm going to say the sine of x equals 0.6. I want to solve for x. So I have to take the inverse sine. So x is going to equal the inverse sine of 0.6. And in this case, when I type that into my calculator, I end up with, to the nearest degree, this ends up being 37. So the angle X in that case is 37 degrees. Okay, what I want you to do here for letter B is go ahead and do this problem, hit pause, do this problem, and then come back to it and see if you get it correct. Very similar to letter A. So see if you can do that. All right, now that you've hit pause, got the answer, let's check it. So from angle X, I have the adjacent side here, and I have the hypotenuse. Well, adjacent and hypotenuse is cosine. So you're using the cosine of X, that's our angle, equals adjacent, which is 15, over hypotenuse, which is 20. Well, that becomes the cosine of X equals 0.75, because I make that a decimal. And now to solve for X, I've got to take the inverse cosine. So it's the cosine inverse of 0.75. When I plug that into my calculator, I get X equals, to the nearest degree, 41. So that's a 41 degree angle. Okay. All right. So now we can figure out any angle that we need to find if we don't know the angle and we know two of the sides. Okay. This concludes sections 8.3 part 3. Don't forget to complete your WSQ.